Okay, polynomials. So we have number 1a. So the question just says check your answer. What is x plus x? Well, what's a cat plus a cat? 2 cats. What's a ball plus a ball? 2 balls. What's x plus x? 2x. Now, what does check your answer mean? Well, as we've learned in earlier chapters, that we just pick a value for x, like 5. X is not equal to 5, so star, it's just an arbitrary x value that we're choosing. Then we're going to put it into the left-hand side, 5 plus 5 equals. Then we're going to put it into the right-hand side. We're not going to answer the left-hand side on the right-hand side. We're going to put it into the right-hand side, substituting for x in for the left and the right. On the left, 5 plus 5 is 10. On the right, 2 times 5 is also 10. Therefore, we can circle our answer 2x, and we know that we are correct. Always checking your answer to make sure until you feel completely comfortable. So now, if we take a look at B, 1b, x times x, x times x. Well, I forgot what x times x is. Well, off to the right, I'm going to say 3 times 3 equals 9. But that answer is not helping me. What else can I call it? I can call it 3 squared, change of base, from last chapter in exponents. So if 3 times 3 is 3 squared, x times x is x squared. So if we pick a random value for x, x equals 4 star. It doesn't actually. And substitute in the left-hand side of the equation, we have 4 times 4. And if we substitute in the right-hand side of the equation, we have 4 squared. And on the left-hand side, 4 times 4 is 16. And on the right-hand side, 4 squared is also 16. Therefore, we can circle our answer, x squared, and we know that we are correct. So, even on a test, if you don't know what something like x times x is or x plus x is and you forget, actually write it down, choose an x value, and put it into your question, put it into your answer. Make sure that they're the same so you can feel confident that you know that that is the correct answer. Okay, we have 2a. Keep in mind, these are last year's questions, but I'm including some of them just to keep our minds going. We have x plus 2 times x plus 3. So we're going to FOIL this thing out. Firsts, outsides, insides, lasts. I rarely use mnemonic devices unless they have exactly what to do with what we're working on. So 1 arrow, 2 arrow, 3 arrow, 4 arrow. So x times x is x squared. X times 3 is positive 3x. 2 times x is positive 2x. And 2 times 3 is positive 6. Then we can combine like terms in the center. X squared. 3x plus 2x is positive 5x plus 6. Circle your answer. Now, did we do it correct? Well, I don't know. Let's pick an x value and put it in. X equals 3 star. It doesn't actually, but we're doing it. So we're going to start by putting it into the question. So we have x plus 2 times x plus 3. So if we put it into x plus 2 times x plus 3, we're going to get 3 plus 2 times 3 plus 3. And that's simply 5 times 6, which is equal to 30. Okay, well now let's take the answer, x squared plus 5x plus 6, and let's put it in. 3 squared. Notice I use brackets when it's more important for substitution. You should do it all the time unless you feel completely comfortable. 3 squared is 9, 5 times 3 is 15, and 15 plus 9 plus 6 is also equal to 30. Whoops, don't circle that answer. That's not an answer. That's a check your answer. So we can put a check mark beside our circled answer. Now, I'm not going to keep checking my answer like I was so often in exponents, but you just know it's a tool that you have. So if you're ever wondering if your answer is correct, don't give some lame reason like the teacher didn't give me the answer, or the answers aren't in the back, or whichever, I can't figure it out. Just put in an x value, see if it's correct in the question and the answer. If it's the same, then you know you're correct. If it's not, it builds your skills. You get to look at all of your steps and decide which step you were the least comfortable with, and go ahead and look at that step first, and then progressively work towards your most confident step, trying to find the error. It also builds you so many more skills like squaring things, substitution, etc. Okay, 2b. So we have 2x minus 1 times x plus 2. Okay, so we're going to do the same process. FOIL, 1, 2, 3, 4. So 2x times x is 2x squared. 2x times positive 2 is positive 4x. Negative 1 times x is minus x, and negative 1 times positive 2 is negative 2. I can combine like terms. 2x squared, 4x minus x is positive 3x, minus 2, circle our answer. So keep in mind, we can do this way faster sometimes. 2x minus 1 times x plus 2. Now, I'm going to show the arrows as I'm doing it. 2x times x is 2x squared. But this time I'm going to do this step and this step at the same time. 2x times 2 is 4x. Hold that thought. Negative 1 times x is negative x. 4x minus x is positive 3x. And then negative 1 times positive 2 is just negative 2. Circle your answer. So it's going to be a lot quicker to not do that middle step and do it in your head. But if you make that mistake a lot, then do it the long way and then combine like terms and do that extra step. Okay, we have C. 2 open bracket, x plus 4, x minus 1, plus 1. So first things first, we are going to FOIL. 1, 2, 3, 4. So x times x is x squared. Now, x times negative 1 is negative x. 4 times x is positive 4x. Negative x plus 4x is plus 3x. And 4 times negative 1 is negative 4. Put the brackets, carry down the 2. You want to make sure you do that FOIL before you distribute the 2. Now we're going to distribute the 2. 1, 2, 3. So 2 times x squared is 2x squared. 2 times positive 3x is positive 6x. 2 times negative 4 is negative 8, and then still plus 1. Now we need to combine like terms. So we have 2x squared plus 6x, and minus 8 plus 1 is minus 7. Circle your answer. So make sure you do the FOIL first, then the distribution of the 2, then add the 1 last, following BEDMAS. Keep in mind, BEDMAS is a preference. It's a law that you cannot break, but we don't have to follow that rule exactly. Okay, 2D. 2D. All right, we got a long one here. X minus 2 minus 2 open, x plus 1, x minus 3. So this first set of brackets are unnecessary. I'm going to scribble them out. Now we're going to do the FOIL first. And x times x is going to be x squared. X times negative 3 is negative 3x. 1 times x is positive 1x. Negative 3x plus 1x is minus 2x. And 1 times negative 3 is negative 3. Brackets around it, put the negative 2 in front, and the x minus 2 in front of that. So now I'm distributing this negative 2 into the brackets. So negative 2 times x squared is negative 2x squared. Negative 2 times negative 2x is positive 4x. And negative 2 times negative 3 is positive 6. Carry everything else down. So now we can combine like terms. So we have negative 2x squared. I'm going to put that in front because we only have one of those. Then we have a couple of x terms. I'm going to cloud them. And we have x plus 4x, which is positive 5x. Then I'm going to put blue circles around the numbers. 1, 2. So we have negative 2 plus 6 is just positive 4. Circle your answer. So for those questions, again, we do the FOIL first, then the distribution, then the combine like terms. FOIL, then the distribution, then we combine like terms. Okay, 2E. So this question looks interesting. We have 3 open, x plus 2, close, squared minus 1. Now, what is x plus 2 squared? Well, can we give the squared to both things and call it x squared plus 4? I don't know. Let's find out. Let's choose an x value. So x equals 3 star. Let's put it in. 3 plus 2, brackets around it, squared. 3 squared plus 4. 3 plus 2 is 5. 5 squared. 3 squared is 9. 9 plus 4. 5 squared is 25. And 9 plus 4 is 13. Those are not equal to each other, so I'm going to put a slash through all those equal signs. Those are not equal to each other. Oh yeah, what does squared mean? It means times by itself. So, that's what squared means. The thing times by itself. Don't make those silly mistakes off to the right. So we can FOIL that out. 1, 2, 3, 4. So we're going to get x squared plus x times 2x times 2 is 2x. 2 times x is 2x. 2x plus 2x is 4x. 2 times 2 is 4. Brackets, carry the 3 down, carry down the -1. Distribute the 3. So we're going to have 3 times x is 3x squared. 3 times 4 is positive 12x. 3 times 4 is 12. Then we have a -1. Then we're going to combine like terms. Sorry about switching the colors. 3x squared plus 12x. And 12 minus 1 is positive 11. Positive 11. Circle our answer. Great. Okay, we have another large looking one, EF. So we have x plus 3 times x squared minus 2x plus 8. Okay, so what are we going to do with this? Well, we have to do what's called a triple FOIL. 1, 2, 3, 4, 5, 6. So following the steps in that order, x times x squared. Oh, what's that again? X times x squared. Well, the x on the left has an exponent of 1, and we're going to add the exponents. X cubed. Okay, so we got x cubed. X times negative 2x is negative 2x squared. X times positive 8 is positive 8x. 3 times x squared is positive 3x squared. Positive 3 times negative 2x is negative 6x. And positive 3 times positive 8 is positive 24. Then we're going to combine like terms. We have x squared. Then we have negative, that's x cubed in the beginning, x cubed. Then we have negative 2x squared plus 3x squared, which is positive x squared. Then we have positive 8x minus 6x, bringing the sign in front. Positive 8 minus 6 is positive, we do that in red because I circled it in red, positive 2x. Then we just simply have the rest of it plus 24. Circle your answer. So we're not going to see too many cubics in grade 10, but there's one. Very classic. Very classic. So being able to do that triple FOIL and combine multiple like terms. Okay, question number 3A. Find the greatest common factor between 15 and 12. The GCF, the biggest number that goes into both of them, is equal to 3. You could do prime factorization and do 15 and get 3 and 5, and you could take 12 and get like 6 and 2 and 2 and 3, and then realize that the biggest number that goes into them is 3 to the 1. But feel free to check out much more elementary finding of the greatest common factor and lowest common denominator of more complicated questions. But usually now it's just going to be much simpler numbers to do. Okay, B. 2x and 6x squared, GCF equals. So the greatest common factor between 2 and 6 is 2, and the greatest common factor between x and x squared, we're going to take the thing to the lowest exponent, 2x. Okay, so just letting you know, I accidentally just did question C, and now I'm going to go back and do question B. We have 6x and 12x. The greatest common factor is simply the biggest thing that goes into 6 and 12 is 6, and then we simply also have an x. Okay, D. We have 2a squared b cubed. We have 3a b to the 4. We have 6a squared b to the 5. And the GCF between the numbers 1, 2, 3, and 1, 3, and 6 is 1. That's the biggest number that goes into those numbers. And then we're going to take the letters, the common letters with the lower exponent. So they all have an a, so we're going to say a, and the lowest exponent of a is 1. So just a, or a to the 1. Then they all have a b, and the lowest exponent of b is 3. And that's going to be the greatest common factor. So, again, not as complicated greatest common factors in this chapter as was in previous grades, where we have to find greatest common factors and lowest common multiples of very complicated numbers. Feel free to go and watch those videos in previous grades. Okay, we have 4a, factor. So we have 2x plus 4. The biggest number that goes into both 2 and 4 is 2. Then 2 times x is 2x, and 2 times 2 is 4. Circle your answer. Let's check this one. So x equals 4 star. So if we write down the question, 2x plus 4, and we write down the answer, 2 open bracket x plus 2, well, we can check our answer. So 2 open bracket 4 close bracket plus 4, the x value that we're randomly choosing, and 2 times 4 is 8, plus 4 is 12. And then we can put into the answer 2 times 4 plus 2, well, brackets first. 4 plus 2 is 6, times 2 is also 12, therefore we can say check mark near our answer. So again, I'm not going to keep doing that, but you're always able to. Okay, B. So we have 4a cubed b squared plus 8a squared b. So the biggest number that goes into both 4 and 8 is 4. The letter that is common with the lower exponent is a squared. And again, the letter that is common with the lower exponent is b to the 1. Then 4 times 4 is just 1. A squared times a is a cubed. And b times b is b squared. Then we're going to remove the greatest common factor from the second. So 4 times positive 8 is positive 2. A squared times nothing. We don't need any a's there. And then we also don't need any b's. So circle your answer. And then I'm just going to redo checking my answer from the last question. So if we do check our answer, we can also check our answer by doing the reverse process. So we can also take our answer and distribute. So 2 times x is 2x, and 2 times 2 is positive 4, which is exactly where we came from. So that's also a valid way. So I'm actually going to distribute in here and make sure that it's correct. So 4, we just have a 4. A squared times a is a cubed. B times b is b squared. Then 4 times positive 2 is positive 4. And then we need an a squared b attached to it. Excuse me, 4 times positive 2 is positive 8. Then we need an a squared b attached to it, and we are exactly where we were. So reversing the process is going to be an extremely valuable tool, being able to check your answer by doing the reverse process. C, negative 4x plus 12. So what's the biggest number that goes into 4 and 12? Well, 4. And I want to take out that negative 4. So what's left? Well, negative 4 times x is negative 4x. And negative 4, a negative times a negative will make the positive, and 4 times 3 is 12. Circle your answer. So now let's do the reverse process. Negative 4, open bracket, x minus 3. If we distribute 1, 2, negative 4 times x is negative 4x. A negative times a negative is a positive. Notice I do those calculations completely separately. Signs, numbers, letters. 4 times 3 is 12. Now, is this exactly where we came from? Absolutely. Check mark near our answers. Oh, forgot to check mark the last answer. Great. Okay, D. So we have negative 8x minus 4, and we're going to remove the greatest common factor. Well, the biggest thing that goes into both 8 and 4 is 4, and I'm going to take out the negative. And take out negative 4. Now, negative times what is a negative? Positive, so nothing. 4 times what is 8? 2. Then we need an x. Then negative 4 times what is negative 4? Well, a negative times what is a negative? A positive. And 4 times what is 1? 4 times what is 4? 1. Close bracket, circle our answer. Take our answer off to the right. Negative 4, 2x plus 1. And check our answer by distribution. 1, 2. Negative 4 times 2x is negative 8x. A negative times a positive is a negative. And 4 times 1 is 4. Circle our answer. Make sure it's exactly the same as where we started. Check mark near our answer. Okay, E. So we have 2x squared plus 5x. Well, the greatest common factor is just x. They both have an x, and the greatest common factor between 2 and 5 is just 1. So all we're going to do is take out an x. Then what are we left with? Well, x times what is 2x squared? 2x. And x times what is positive 5x? Positive 5. Circle our answer. Now, I could keep checking our answer, but I think people are getting bored of checking our answer on every single question we do. So now we're just going to do it in our heads. X times 2x is 2x squared. X times 5 is positive 5x. Therefore, we are correct because that's exactly what it says above. Okay, F. So we have 10x cubed minus 5x squared. Well, what's the biggest number that goes into both 10 and 5? 5. And they both have a common letter, so x. And the lowest exponent of that common letter is 2. Then 5 times 2 is 10. X squared times x is x cubed. A positive times a negative is a negative. 5 times 1 is 5. And x squared times, we don't need anything because it's already an x squared. Circle your answer. Check our answer by distribution in our heads. 5 times 2 is 10. X squared times x is x cubed, and that's exactly what it says above. 5x squared times negative 1. Positive times a negative is a negative. 5 times 1 is 5. And x squared times nothing there is x squared. Because 5x squared times negative 1 is negative 5x squared. Check our answer. All right, 7b. So we have 6x plus x squared plus 8. So this isn't in a nice clean format, so we'd rather rearrange the order of the terms. X squared plus 6x plus 8. Okay, so off to the right, two numbers that multiply together to make 8 and two numbers that add together to make 6 are 2 and 4, and again 2 and 4. So we can factor it. X plus 2, x plus 4, circle your answer, check your answer by distribution. X squared plus 4x plus 2x plus 8. 2x plus 4x is 6x, therefore check mark, our answer is correct. Okay, C. X squared plus 5x plus 8. Well, blank times blank equals 8. Two numbers that multiply to get 8 and two numbers that add to get 5. Numbers that multiply to get 8 are 1 and 8 and 2 and 4. Do either of those combinations make 5? No. Does not factor. Most things don't factor. We just present you with questions that do and then teach you how to do that process. Most questions don't factor. But the questions that they give you are probably going to factor if they ask you to factor. Just remember that most questions don't factor. Okay, D. So we have negative 4 plus x squared plus 3x. So we need to start by rearranging the order of the terms. So we're going to put our x squared term first, then 3x, then the negative 4, keeping the signs with them. So off to the right, two numbers that multiply to get negative 4, and two numbers that add to get 3. Numbers that multiply to get 4 are 1 and 4, and 2 and 2. Which combination makes 3? 1 and 4. So we start by putting 1 and 4 in the blanks. Then we decide, looking at the addition statement, which one needs to be negative. The 1. Then we put the negative above and confirm that the multiplication statement works. Yes, negative 1 times 4 is negative 4. Negative 1 plus 4 is positive 3. So we can factor it to those numbers. X minus 1, x plus 4. Circle our answer. Foil it out. X times x is x squared plus 4x minus x, or minus 1x, minus 4. 4x minus x is 3x, and that's what we have above. Check mark near our answer. Okay, 7e. So we have x squared minus 3xz minus 18z squared. So this question is very similar to the old ones, but now we have a z and a z squared here, and I'm just going to teach you the idiosyncrasy. So still, two numbers that multiply, blank times blank equals negative 18, and two numbers that add to get negative 3. Blank plus blank equals negative 3. Numbers that multiply together to make 18 are 1 and 18, 2 and 9, and 3 and 6. So the only ones of those combos that can make 3 are 3 and 6. Then again, we're going to look at the addition statement and realize that the 6 needs to be negative, put that negative above, confirm that the multiplication statement works, and then we can go ahead. So that's x plus 3 and x minus 6. But because we have a z, we just need a z. Circle our answer and foil it out. X squared minus 6xz plus 3xz minus 18z squared. Negative 6xz plus 3xz is the number from above. Negative 3xz, therefore we know we've done it correctly. All right, we have 8a, factor the following. So we have 2x squared plus 7x plus 6. So, first of all, is a 1 or is a not 1? A is not 1. So We're going to put an arrow from the 2 to the 6, and we're looking for two numbers that multiply together to make 2 times 6 is 12, and still two numbers that add to get 7. So two numbers that multiply to get 12, the numbers that multiply to get 12 are 1 and 12, 2 and 6, 3 and 4. Which ones make 7? 3 and 4, so 3 and 4, 3 and 4. So this time we're going to do it differently. We're going to break up this middle term into those two terms. So we have 2x squared plus 4x plus 3x plus 6. So then we're going to follow a step that we've learned previously. Grouping. Brackets around the first two things, brackets around the second two things. Don't cut off the sign. Then we're going to GCF twice. So the first set has a greatest common factor of 2x. And then we're left with 2x times what's 2x squared? Just positive. And 2x times what is 4x? 2. Then we'll remove a greatest common factor of 3, and 3 times x is 3x, and 3 times positive 2 is 6. Therefore, we have a greatest common factor of x plus 2, and we're left with 2x plus 3. Circle our answer. So that's going to be the slow way, and there's a little bit faster of a way. 2x squared plus 7x plus 6. So we set up the brackets, and then we know the first step of FOIL is the first thing times the first thing. So what two things multiply together to make 2x squared? Well, 2x and x. Then we have to think, what multiplies to get 6? Well, it can be 1 and 6 or 2 and 3. So there might be a 1 here and a 6 here, or there might be a 2 here and a 3 here, but it's very difficult to figure that out. So it's a lot more guess and check style. So if you do like a guess and check style and you don't like processes as much, feel free to try that process. I know some teachers just teach that way. But decomposition is going to be the process on the left, which we absolutely know is correct. Let's FOIL it out. X times 2x is 2x squared. Then we have plus 3x plus 4x plus 6, and 3x plus 4x is 7x. So it is exactly the same as we were. Check mark. Okay, B. So we have 2x squared minus 3x minus 2 equals 0. So we're going to factor it. Two numbers that multiply, blank times blank equals. Well, are we looking for two numbers that multiply to get negative 2? No, we're going to multiply the number in front by the last thing. So if we distribute, two numbers that multiply to get 2 times negative 2 is negative 4, and two numbers that add to get negative 3. The numbers that multiply to get 4 are 1 and 4, and 2 and 2. The only combinations that make 3 are 1 and 4, again 1 and 4. Looking at the addition statement, we'll realize the 4 has to be negative, put the negative above, and make sure that it works. Negative, or 1 times negative 4 is negative 4. So we can separate, so we'll have 2x squared plus 1x minus 4x minus 2 equals 0. Then continuing, so we can factor out an x, and we're left with 2x plus 1. We can factor out a negative 2, and we're left with 2x plus 1. Whoops, I don't know why I said equal to 0. Sorry about that. I'm going to erase that. That's a grade 11 thing. Okay, they both have a 2x plus 1. We're going to take out a 2x plus 1, and we're simply left with x minus 2 and 2x plus 1. Circle your answer. Now we could continuously FOIL these things out to make sure that the answer is correct, but we've done enough of that for now. Okay, C. 5x squared plus 12x plus 1. So, first number times the last number is 5. Two numbers that multiply to get 5 times 1 is 5. Two numbers that add to get 12. Numbers that multiply to get 5 are 1 and 5. Under no circumstance can those make 12. So, does not factor. So that's going to happen, remember, sometimes. Okay, D. So we have 3x squared minus 5x minus 2. A is not 1, so if put an arrow from the first number to the last number. Two numbers that multiply to get blank times blank equals 3 times negative 2 is negative 6. Two numbers that add to get negative 5. Numbers that multiply to get 6 are 1 and 6, and 2 and 3. So notice both of these combinations makes 5. So we have to decide what number goes where. So let's try, first of all, 1 and 6. Again, 1 and 6. Which one needs to be negative? The 6 in order to get negative 5. 1 plus negative 6 is negative 5. Put the negative above and it works. If you had tried 2 and 3, you would have recognized after that it did not work. So we're going to separate it. 3x squared plus 1x minus 6x from off to the right. Then we can remove a greatest common factor. And then again, we can remove a greatest common factor of negative 2, and we're left with 3x plus 1. They both have a 3x plus 1, so we can take out a 3x plus 1, and we're left with x minus 2. Again, FOIL your answer to check it out. Make sure that it's correct. So be very careful about when a is 1, when two numbers just multiply together to make the last thing, or when a is not 1, where two numbers that multiply to get the first number times the last number. Always putting in an arrow from the first number to the last number when a is not 1 as a reminder. Okay, number 9. Things that look like they are interesting. So we have x squared plus 4x plus 4. So we're going to factor this thing. Two numbers that multiply to get 4 and add to get 4 are 2 and 2. So blank times blank equals 4, and blank plus blank equals 4. Those numbers are 2 and 2. Therefore, this is going to factor to be x plus 2, x plus 2, and we're going to call that x plus 2 all squared. Take your answer off to the right and check your answer. X plus 2 times x plus 2. FOIL it out. X squared plus 2x plus 2x plus 4. So we know that we are correct. 2x plus 2x is 4x. Therefore, we can put a check mark beside our answer. So these questions are called perfect squares because they turn into two brackets that are identical, and then they are that bracket squared. So if we take a look at B, we have x squared minus 6x plus 9. So two numbers that multiply to get 9, and two numbers that add to get negative 6. So numbers that multiply to get 9 are 1 and 9 and 3 and 3. And the numbers that multiply to get 9 that add to get 6 will be 3 and 3. And then looking at the addition statement, which one or both need to be negative, or neither, both. Therefore, it factors to be x minus 3, x minus 3, or x minus 3 squared. Now, as I said before, we're not going to keep checking our answer on every single question we're going to do, so I'm going to let you go ahead and FOIL that thing out and make sure that it's correct. Okay, so C, 9x squared plus 12x plus 4. Now, it may kind of look like we're going to be doing decomposition. Two numbers that multiply to get the first number times the last number is 36, and two numbers that add to get the middle number 12. Well, those numbers are going to be 6 and 6. Now, we could do decomposition, and we could split up the 12 into 6x plus 6x and continue. But what we want to recognize is that the square root of the first number times the square root of the last number doubled is 3 times 2 times 2 is 12. Because that is the middle number, we know this thing is a perfect square, and we can just set up our brackets. Then we just think, what are two identical numbers that multiply together to make 9x squared? That's 3x and 3x. And what are two numbers that multiply together to make 4 identical? That's positive 2 and positive 2. We can call this thing 3x plus 2 all squared. So for the next two questions, we're going to be doing that exact same process. These things are called perfect squares because the square root of the first number times the square root of the last number doubled is the middle number of some kind, positive or negative. So we have D. So 4x squared minus 4x plus 1. Well, the square root of 4 times the square root of 1 doubled is equal to 2 times 1 times 2, and that's 4. And that's the middle number, therefore it will work. Now, positives and negatives will come into consideration, but these ones are nice and simple. So, set up our brackets. What two identical numbers multiply together to make 4x squared? 2x and 2x. What two identical numbers multiply together to make 1? 1 and 1. Now we need to think, if we were to FOIL this thing out, the last step would be 1 times 1. Now, we need to get positive 1 above, so both either need to be positive or both need to be negative. Now, they both need to be negative, so it works. If we FOIL it out, I'll check this answer. So 2x minus 1, close bracket squared, is going to be our final answer. Let's take that thing off to the right. 2x minus 1 times 2x minus 1. This FOIL process should be in your mind the whole time when you're doing these questions, always doing the reverse operation to make sure you did it correctly. 2x times 2x is 4x squared. 2x times negative 1 is minus 2x. Negative 1 times 2x is negative 2x. Negative 1 times negative 1 is positive 1. And minus 2x is negative 4x, the term in the center. Therefore, we are correct. Okay, E. So we have 4x squared minus 20x plus 25. Well, the square root of 4 times the square root of 25, doubled, is 2 times 5 times 2, which is 2 times 5 is 10, times 2 is 20, and I forgot a 0 in the middle there. Notice I just changed negative 2x to be negative 20x. I copied the question out incorrectly. Okay, so we're just going to factor it. So we can just say set up our brackets, and two numbers that multiply together to make 4x squared are 2x and 2x. And two numbers that multiply together to make 25 are 5 and 5. And they both need to be negative in order to get negative 20 for the middle term. We can then say 2x minus 5 all squared. Check your answer. Awesome, so those things are perfect squares. Again, they could be done by decomposition, but we want to recognize when it is a perfect square. Square root the first number, square root the last number, double it. If that's the middle number, positive or negative, then it works. Notice the first and the last term both need to be positive or both need to be negative if that was the case. All right, number 10a. So we have x squared minus 25. So if the first thing can be square rooted and the second thing can be square rooted, we know it's a perfect differences of squares. So we can say x plus 5, x minus 5. Circle your answer. Check your answer. X plus 5, x minus 5. So when we FOIL this thing out, we're going to get x squared minus 5x plus 5x minus 25. Negative 5x plus 5x cancel, so we're going to get x squared minus 25. Therefore, our factored answer, x plus 5x minus 5, is correct. So again, called differences of squares. Okay, let's take x squared minus 121. Well, we recognize that 121 square rooted is 11, so the answer is x plus 11, x minus 11. Circle your answer. Okay, C. X squared plus 1. X squared plus 1. So, we can factor a difference of squares if there's a minus sign, but not a sum of squares. Does not factor. Try and choose something. X plus 1, x plus 1, x minus 1, x minus 1, x plus 1, x minus 1. FOIL it out and realize that none of them work. Okay, D. 1 minus x squared. So this time we do have a differences of squares. So we can say 1 minus x, 1 plus x. Circle your answer. Notice the order is different. The 1 is first, so 1 times 1 is 1, and the x is second, so we get negative x times x is negative x squared. Okay, E. Negative x squared plus 49. So is this a differences of squares? Well, sure, we could turn it around. So we could say 49 minus x squared. Then it factors to be 7 minus x, 7 plus x. Now we could have done it a little bit differently. We could have taken the negative and factored out the negative. Negative open bracket, x squared minus 49. Then said negative open, x plus 7, x minus 7. Circle your answer. Fill both of these answers out and make sure that they're completely identical. They have to be. We didn't break any laws. Okay, F. 9x squared minus 1. Well, we can square root 9, that's 3, and we can square root 1, that's 1. So if we set up our brackets, it's going to be 3x times 3x is 9x squared, and 1 times 1 is 1. We need a plus and a minus. Circle your answer. Okay, G. Let's see how many we can fit up here. G. So 16x squared minus 25. 16x squared minus 25. So we have a differences of squares. So we're going to factor it. And two numbers that multiply together to make 16x squared are 4x and 4x. And two numbers that multiply together to make 25 are 5 and 5. And we can say plus minus. Circle our answer. Okay, H, a little interesting one. A squared minus b squared. Well, this is a difference of squares, and two numbers that multiply together to make a squared are a, and two identical numbers that multiply together to make b squared are b and b, and we can say plus and minus, and circle your answer. I. 4x squared minus 9y squared. So we can square root 4, we can square root 9, we can square root x squared, and we can square root y squared. So we can set up our brackets. And two identical numbers that multiply together to make 4x squared are 2x and 2x. And two identical numbers that multiply together to make 9y squared are 3y and 3y. And we can say plus, and we can say minus, and we can circle our answer. J, x squared minus 2. So we can't square root 2, but we still can. So this thing factors. Two identical numbers that multiply together to make squared are x and x. And technically, two numbers that multiply together to make 2 are root 2 and root 2. Interesting little trick. So notice in the first question, all we did was square root 25 to figure out what goes inside the brackets. In the second question, we just squared it at 121 to figure out what's inside the brackets. So in the question that we were just working on, J, we just square rooted the thing and put it inside the brackets. Okay, K. So we have x to the 4 minus 81. So this is going to factor interestingly. First of all, two identical numbers that multiply together to make x to the 4 are x squared and x squared. Two identical numbers that multiply together to make 81 are 9 and 9. Then we can say plus, and then we can say minus. Now the first set of brackets is a sum of squares. We can't touch it. But the second set of brackets is a differences of squares, so we can keep going. X plus 3, x minus 3. So interesting, sometimes we're going to have to factor it by differences of squares twice. Okay, K, I'm doing in red and I'm not skipping a line because I'm running out of space. Sorry, K-L, H-I-J-K-L, excuse me, L. Which says x to the 6 minus 144. So we're going to set up our brackets. And two identical numbers that multiply together to make x to the 6 are x cubed and x cubed. If we remember from exponents, if we're multiplying with the same base, we add the exponents. So x cubed times x cubed is 3 plus 3, 6, x to the 6. And then we can say plus 12 and minus 12, because those are the two numbers that multiply together to make 144. And then notice we have a cube, so it can't go again, like a fourth may be able to do. Okay, so that whole page is on differences of squares. Notice where there are some combinations, all sorts of different variables and order of operations, and possibly move the greatest common factor of -1. A lot of great examples on differences of squares. All right, 11a. So we have 3x squared plus 15x plus 18. Now we could try and factor by decomposition, but we'd rather try and remove the greatest common factor first if we can. So the greatest common factor between 3, 15, and 18 is 3, so we can pull out a 3, and we're left with x squared plus 5x plus 6. And two numbers that multiply to get 6 and add to get 5 are 3 and 2, so we have x plus 2, x plus 3. Circle your answer. So remember, always remove the greatest common factor first if you can. B, 2x cubed minus 4x squared minus 30x. So this time we can not only take out a 2, because it's the greatest common factor between 2, 4, and 30, but we can also factor out an x. So we can say 2x open. So 2x times what is 2x cubed? Well, x squared. Then 2 times -2 is -4, and then we need an x. Then 2 times -15 is -30, and then we don't need an x. Then we can factor the brackets. So let's say 2x, haven't touched it. Two numbers that multiply to get 15, blank times blank equals -15, and two numbers that add to get -2 are 5 and 3, 5 and 3. The 5 needs to be negative, put that above, confirm the multiplication statement works, and we get x minus 5, x plus 3. Circle your answer. Okay, C. So we have -x squared minus 5x plus 14. So we don't like that negative out in front, so we're going to factor that negative out first. So we get negative open, x squared plus 5x minus 14, changing the signs. Two numbers that multiply together to make -14, and two numbers that add together to make 5 are 7 and 2, and the 2 needs to be negative. So we can say negative open, x plus 7, x minus 2. Remember, we're factoring out the coefficient of x squared if we can, so we get a 1 in front of x squared, and then we can factor it in this simple way, and we don't have to do decomposition. Again, very careful with the coefficient of x squared. Okay, D. 27x squared minus 48. Well, the greatest common factor between 27 and 48 is 3, so I'm going to take out a 3. Oh, and then I'm left with 9x squared minus 16. Then notice I have a differences of squares inside the brackets. So we have a 3 out in front, set up our brackets. Two identical numbers that multiply together to make 9x squared are 3x and 3x. And two identical numbers that multiply together to make 16 are 4 and 4, and one needs to be positive and one needs to be negative. Circle your answer. All right, so those are combination factoring questions, removing a greatest common factor, then factoring trinomials, possibly a negative, possibly an x, possibly just a number, then factoring it however we learned before. So combination factoring. Okay, 12a. So we have x squared plus 2/3 x plus 1/9. Now we're working with fractions, so we have to, well, a is 1. And we're working with fractions, so still two numbers that multiply together to make the last number, and two numbers that add to get the middle number. So the only numbers that multiply together to make 1 are 1 times 1, and the only numbers that multiply together to make 9 are 1 and 9, or 3 and 3. So we have to put 1s on the top, so 1 and 1. Then the only numbers that multiply together to make 1 and 9 will be 1 and 9, or 3 and 3. Now we're going to use 3 and 3, because if we put those numbers down below, 1/3 plus 1/3 is 2/3. So this is going to factor, so we have x plus 1/3, x plus 1/3 turns out to be a perfect square. Circle our answer. So those fractions are going to be a lot more difficult. So often trial and error is just the best method. Some people like to remove a greatest common factor first. That's fair. So for example, what if we take x squared plus 2/3 x plus 1/9? Well, we want to remove the denominators. And in order to do that, we're going to have to take out 1/9. So 1/9. Then we'd be left with 9x squared plus, well, 1/9 times what equals 2/3? Well, we need to cancel. So we're going to need a lot more factors on the top. We're going to need at least a 9 on the top. So I'm just going to say 9 times 2/3. That's what we need to cancel the 9s. Now 9 times 2 is 18, over 3 is simply 6, and that's why 6x goes here plus 1, because 1/9 times 1 is 1/9. So now let's factor it. So let's recognize that the square root of 9 times the square root of 1 times 2 is 3 times 1 times 2, which is 6. So this thing is a perfect square. So we can say 1/9, then we can set up our brackets, and two identical things that multiply together to make 9x squared are 3x and 3x. And two identical numbers that multiply together to make 1 are 1 and 1, and they both need to be positive in order to get 6. So check your answer by FOIL. So top right, that process of figuring out which fractions multiply together to make a number and add together to make a number when they're all fractions is a very difficult process. And lots of the time, trial and error will be your best bet. Or remove a greatest common factor if you don't like the fractions, but you still have to deal with the fractions anyways, and then do some kind of a decomposition on the rest of it. Okay, 12b. This time we have a 1/6 in front, minus 2x, minus 18. So let's take that 1/6 out in front. We never like that if that's there, if we can. Now we want to think what goes there. Well, top right, really easy question, 2x plus 4. We know we can remove a greatest common factor of 2. Then we're left with x plus what? Well, 4 divided by 2 equals 2, so that's what goes there, 2. So if I take the -2, or the 2 for that matter, and I divide it by 1/6, it means I'm dividing by 1/6, which means that it's just -2 times 6/1, which is 12. So minus 12, I forgot the negative, minus 12x. And then for the same principle, if we take that out of -18, if we go -18 divided by 1/6, and we flip and multiply -18 times 6/1, then we multiply, -18 times 6/1 will be 60 plus 48, or -108. So -108. So now, if we factor that thing, what are two numbers that multiply together to make 108 and add to get -12? So let's set that up. blank times blank equals negative 108, and two numbers that add to get 12, negative 12, excuse me. So those numbers are going to be, if you start listing all the factors, we have 1 and 108, 2 and 54, 3 and, I'm not exactly sure at the moment, 108 divided by 3 is 36. 108 divided by 4 will be 27. 5 doesn't go in. Let's try 6. 6 and 18. There it is. 6 and 18 make 12. So we can say 6 and 18. Again, 6 and 18. Now, which one needs to be negative? The negative 18. So then we can factor it. So I'm going to skip some lines to show those steps. 1 over 6, x plus 6, x minus 18. So combo factoring, removing the greatest common factor, working with fractions, and very difficult numbers. Okay, 12c. We have t squared plus 0.2t minus 0.15. Well, two numbers that multiply together to make negative 0.15, and two numbers that add together to make 0.2 are 0.5 and 0.3 and 0.5 and 0.3, and the 0.3 needs to be negative. So this thing's going to factor nicely to simply be t plus 0.5 and t minus 0.3. So interesting factoring, right? They were decimals. We could have turned those into fractions and then dealt with fractions. So we could have taken t squared and said plus 0.2 is 2 over 10, or simplified 1 over 5. And then 15 over 100, 0.15 is 15 over 100. And 15 over 100, if we divide the top and bottom by 5, we're going to get 3 over 20. And then that will factor to be two numbers that multiply together to make 3 over 20 negative, and two numbers that add to get 1 over 5. Well, this is going to be a lot more difficult. So notice we just did it above. So we know the numbers are 0.5 and negative 0.3. So we have 1/2 and 1/3. Excuse me, 3 over 10. So that works. And then if we try those numbers down below, well, do those add to get 1/5? Well, let's find out. So 1 over 2, if we times the top and bottom by 5, plus 3 over 10, will equal 5 over 10 plus 3 over 10, which is equal to 8 over 10. Whoops. So, oh my gosh, haha. This 3 needs to be negative in order to multiply to get that. Again, it needs to be negative. Again, it needs to be negative. And then I'm going to cross out my answer. It needs to be negative. And then we're going to get 5 minus 3 is 2 over 10, or more simply, 1 over 5, what we were looking for. So be very careful with your positives and negatives. So this thing factors to be t plus 1/2, t minus 3 over 10. Awesome. Very difficult fractions. Be careful with your positives and negatives. You may not like decimals, convert into fractions, whichever. Okay, D. We have 0.02 x squared plus 0.05 x minus 0.03. Okay, so we're going to remove our greatest common factor. We're going to remove the coefficient of the x squared term and see if it makes it simpler for us. And then remember, if we want to figure out what goes inside the brackets, we just do 0.05 divided by what we took out. 0.05 divided by 0.02 is simply 2.5, which is 2.5, which is 5 over 2, plus 5 over 2, x. Then if we take 0.03 negative and divide it by 0.02, we're going to get 0.03 divided by 0.02, which is going to be equal to 1.5, or equal to 1 and 1 over 2, or equal to 3 over 2. So minus 3 over 2. Then we can factor it. So two numbers that multiply together to make negative 3 over 2, and two numbers that add together to make 5 over 2. Well, again, this stuff is very difficult. I'm just going to help you with it. And again, it's just trial and error, trying things that work, figuring it out. So I'm going to go with negative 3 and 1/2, because the 3 is over 1 and it works. So let's try those numbers. So if we add those fractions, negative 3 over 1, if we times the top and bottom by 2, and we add 1/2, that's going to be negative 6 over 2 plus 1/2 equals, that would give us negative 5 over 2. So I gave the negative to the wrong thing. I'm going to give this plus and make the other one negative. Get rid of that plus, get rid of that plus, call this plus, and 6 minus 1 is positive 5 over 2. Very difficult. So let's factor that thing. So we have 0.02, open, x plus 3, and x minus 1/2. Circle your answer. So keep in mind, they may ask for all sorts of different things, like no fractions in the answer, or remove a greatest common factor of this, or all sorts of things. They might be specific as to what type of answer they want. But notice how difficult that process is off to the right. Okay, E. So we have 1 over 25a squared minus 1 over 36. So we want to recognize that the square root of 1 over 25 is just 1/5, and the square root of 1 over 36 is just 1 over 36. So it's a differences of squares. And it's going to be factoring two identical numbers that multiply together to make 1 over 25 are 1 over 5 and 1 over 5. We need an A, and two identical numbers that multiply together to make 1 over 36 are 1 over 6 and 1 over 6. And one of them is going to be a plus and one of them is going to be a minus. Again, you could have removed some sort of a greatest common factor to make that process a little bit simpler. So, for example, no, I'm not going to. Oh my gosh. Okay, so great, yes. Make sure you follow the teacher's instructions as to exactly what to do. So, then we have F. So we have 0.25 x squared minus 1. So 0.25, well, that's a fraction. That's 25 over 100, or even better, 1 over 4. X squared minus 1. This is a differences of squares, so we can set up our brackets. Two identical numbers that multiply together to make 1 over 4x squared are 1/2 x. Again, 1/2 x. And two identical numbers that multiply together to make 1 are 1 and 1, and positive, negative. Circle your answer. Feel free to FOIL it out to make sure that it's correct. Okay, 13a. So we have x plus 1 squared minus x plus 1 minus 12. So notice we could just FOIL this thing all out, get a big long thing, combine like terms, and then factor it, but we're going to do it in a different way. So we're going to let our favorite letter, M, equal x plus 1. So now we can, everywhere we see an x plus 1, we can put m in for it. So we have m squared minus m minus 12. Now we can factor it. So two numbers that multiply together to make negative 12 and add together to make negative 1 are m minus 4 and m plus 3. Now we have to take what we made for m and put it back in. So if we take x plus 1 and we put it back in for m, whoops. But I forgot to substitute with brackets. Whoops. Excuse me, putting x plus 1 back in for m. Great, so none of those brackets that we just used for substitution are necessary, so I can scribble them out. But I put them there in case there's negatives in front. So 1 minus 4 is negative 3, so we get x minus 3. And 1 plus 3 is 4, so we're going to get x plus 4. So we're going to call that factoring by substitution, letting m equal something that is there. And then factoring it, then bring m back in so we don't have to do some crazy FOIL, expand it all, combine like terms, possibly make a mistake. And especially because we're going to be using this method many times in the future, factoring by substitution or any sort of substitution. Okay, B, we have 2x plus 3 all squared plus 3x plus 3 minus 9. So we've got a thing, so we can let m equal x plus 3. Then we can put it in. 2m squared plus 3m minus 9. Now, again, we could do decomposition, but go back and learn how to do decomposition carefully. I'm just going to do it the quick way. So I'm going to set up my brackets. And the only two things that multiply together to make 2m squared are 2m and m. Then the things that multiply together to make 9 are 1 and 9, or 3 and 3. Now, we have to get 3 in the center. We have to get 3m in the center. Therefore, we know we have to be 3 and 3, and we have to be in this exact order. We have to put the plus 3 here, and the minus 3 here. Those numbers are going to multiply together to make negative 9. I'm going to circle my answer, and I'm going to check my answer by FOIL to make sure it's correct. 2m times m is 2m squared. 2m times positive 3 is positive 6m. Negative 3 times m is negative 3m. And then we have negative 3 times positive 3 is negative 9. Now these middle two terms, plus 3m minus 3m, is exactly what we have above. 6m minus 3m is 3m. Therefore, we know we did it correct. So this process off to the right, figuring out which numbers goes in, is very difficult. If that is difficult for you, make sure that you do decomposition. Then always check your answer, because checking your answer makes you understand the most why the numbers go in their locations. And just the practice of foiling it out, even if it's just in your head, is exactly the process that people are doing to figure out what number goes inside the brackets. Okay, C. X plus 1 squared minus 4. So we want to recognize that this is the differences of squares. I'm going to let m equal x plus 1. Then I'm going to put m in, so we're going to get m squared minus 4. Now this thing's going to factor to be m plus 2, m minus 2, a differences of squares. Then I can substitute m back in. Now I don't need extra brackets because there's no negatives or numbers in front to distribute. So then we have 1 plus 2 is 3, and 1 minus 2 is negative 1. Factoring by substitution, so we don't have to FOIL it out, and practicing skills for the future. Okay, D. 9 minus x minus 2 squared. So let's let m equal the funny looking thing, x minus 2, and let's put it in. So we're going to get 9 minus m squared. That's going to factor to be, 3 plus m, 3 minus m, according to differences of squares. Now we have to carefully put m back in. I'm going to do this in red this time. So 3 plus. Now we have to substitute with brackets. Now, these first set of brackets are unnecessary because there's no plus, there's just a plus sign in front, but these second set are important. So we have to distribute the negative into the second set. So the first set, we have x, 3 minus 2 is 1. Then we have 3 minus x plus 2. Clean it up, x plus 2. 3 plus 2 is 5. And we have a minus x. Circle your answer. So be very careful with substituting back in, making sure when the brackets are necessary. Anytime there's a number or a negative in front of brackets that you have to substitute, it absolutely matters. If you're ever questioning it, just substitute with brackets all the time and then just recognize every time that they're useless. But making sure that we distribute that negative or whatever number's in front of the brackets. Okay, E. Oh, a little more complicated. So we have x plus 2 squared minus x minus 3 squared. Okay, interesting. So this time I'm going to let two different letters. I'm going to let m equal x plus 2, and I'm going to let n equal x minus 3. So then I can put it in. So we're going to get m squared minus n squared. Now this is the differences of squares that we can factor. M plus n, m minus n. So then we can take m and n and very carefully substitute them back in. So the m's don't have negatives or numbers in front, so we can substitute them straight in. Then the n, this n, doesn't have a negative in front, so I can substitute it straight in. This m doesn't have a negative or a number in front of it, so I can substitute it straight in. But this n has a negative in front of it, so I have to use brackets for my substitution. So then we can combine like terms. So the first set of brackets, we have x plus x, which is 2x, and 2 minus 3 is negative 1. Then we have x plus 2 minus x plus 3, distributing the negative. So we're left with 2x minus 1, and x minus x is gone. 2 plus 3 is 5. And let's pull that 5 out in front. So be very careful with your let statements and very careful with the substitutions when you need brackets for those substitutions. Okay, 13F. So we have x squared plus 6x plus 9 minus y squared. Interesting question. We're going to do an interesting form of grouping. We're going to group the first three terms. Then we're going to factor the first three terms. Two numbers that multiply together to make 9 and add to get 6 are 3 and 3. So we can say x plus 3 minus y squared. Then we can factor it. So we're going to get x plus 3 squared, or simplify it, minus y squared. X plus 3 times x plus 3 is just that. X plus 3 all squared. Then we can make m equal to x plus 3. We can clean it up. M squared minus y squared. We can factor a differences of squares. M plus y, m minus y. And then continue. So then we can take x plus 3 and put it back in for m. And there's no negatives in front, so no problem. That's an x. X plus 3 minus y. Now we don't have any like terms, so we can circle our answer. So we call that partial factoring, when you can recognize a part of something that can be factored by grouping that one part, factoring it by itself, and then seeing if you can recognize another factoring method along the way. Okay, 14a, x squared plus kx minus 10 equals, minus 10. Okay, so it says find k so it will factor. So we initially start these problems by two numbers that multiply together to make negative 10 and add to get k. So if we set that up, blank times blank equals negative 10 and blank plus blank equals k. So what are numbers that multiply together to make negative 10? Well, we have 1 times negative 10. We have 10 times negative 1. We have 2 times negative 5. And we have 5 times negative 2. So if we add those numbers, 1 plus negative 10 is equal to negative 9. 10 plus negative 1 is equal to 9. 2 plus negative 5 is equal to negative 3. And 5 plus negative 2 is equal to 3. Therefore, if k is equal to plus or minus 9 or plus or minus 3, then we are factorable. These questions are interesting. Find k so this thing factors. I could check my answer by taking any of those numbers, substituting them for k, and factoring it. Let's try 1. So x squared, let's go for positive 9. X minus 10. Two numbers that multiply together to make negative 10, and two numbers that add together to make positive 9. Those numbers are 10 and 1. Again, 10 and 1. The 1 needs to be negative to make both statements true. So it'll factor to be x plus 10, x minus 1, if k was 9. So you can try the other 4 examples, but we know that we are correct. Okay, 14b. 3x squared plus kx minus 10. So two numbers that multiply together to make negative 30, the first number times the last number, and two numbers that add to make k. So the numbers that multiply together to make 30 are 1 and 30, 2 and 15, 3 and 10, and 5 and 6. And in either of those cases, one of those numbers needs to be negative. So, therefore, k can equal 30 and negative 1 makes 29, and then negative 1 and the reverse, we know it plus and minus 29. So it's just going to be the difference between those numbers. So then if we have 2 and negative 15, we're going to get 13. And then if we have the reverse, it's going to be negative 13, so plus and minus. 10 and negative 3 make 7, and negative 10 and positive 3, negative 7, so plus and minus. And then 5 and 6, if one of them's negative, we're going to get 1, so we're going to get plus and minus 1. So faster ways to figure out what those numbers work out to be without actually writing them all down and calculating them all. But if that is difficult for you, then make sure you did exactly what I did above and write down all the combinations and figuring out what k could be. Okay, we have x squared plus 8x plus k. So, two numbers that multiply together to make k, that add to get 8. So keep in mind, like, 1,000,008 minus 1,000,000 is 8. Again, 1,000,008 minus 1,000,000 is 8. 2,000,008 minus 1,000,000 is 8. So there's way too many combinations. They're going to say something like, find 4 values of k or something. So we just figure all the numbers that add to get 8. So 1 and 7 adds to get 8. 2 and 6 adds to get 8. 3 and 5 adds to get 8. And 4 and 4 adds to get 8. So then we just figure out what those multiply together to make for k. So k equals 1 times 7 is 7. K equals 2 times 6 equals 12. 3 times 5 equals 15. 4 times 4 equals 16. So any of those combinations of k, any of those k values, allow this thing to be factorable. Again, there's an infinite number of k values with a question like this. So they're going to specifically say, find 4 k values, or find all the k values below 20 or something. Okay, 14d, kx squared plus 3x plus 2. So two numbers that multiply together to make 2k, and two numbers that add together to make 3. So again, there's going to be so many multiple answers, but let's just find one k value that works. So what multiplies together to make 3? Well, 1 and 2, excuse me. So if I put those numbers above 1 and 2, well, then we can think 1 times 2 is equal to 2k, and because 1 times 2 equals 2, we know k is simply just 1, because 2 times 1 equals that. 2 times 1 equals 2. So if I put a 1 in front, circle my answer, k equals 1. If we put a 1 in front, x squared plus 3x plus 2. This thing factors. Two numbers that multiply to get 2 and add to get 1 when a is 1 are x plus 2 and x plus 1. Again, keep in mind, so many different ways to factor these things. There are just so many. So k was 1. This was a nice simple example, but keep in mind there's going to be more k values that could possibly work. They're going to specifically ask you if they want a k value, more than one k value, etc. Okay, E. So we have x squared minus k, x squared minus k. So we know that this could potentially be a differences of squares. So let's start squaring stuff. 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16. K could be any perfect square. K equals 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. It could be any perfect square. Notice they could only be positive, they couldn't be negative, because then if it was negative, then you'd have a sum of squares. So keep in mind, again, they're going to specifically ask you, find a k value, or find more than one k value, or find all the k values. Okay, we have 2x squared minus 9x plus k. And they're saying to us that x minus 4 is a factor. So we can set it up, and we can put x minus 4 in one of the factors. Now, if we start to FOIL it out, first times first, what times x is 2x squared above? 2x. Then we'll actually start FOILing. So we'll get 2x squared. Second step, minus 8x. Then we don't know, plus something x. Then plus or minus, I'm going to say minus something times 4. I'm actually going to say plus times negative 4. Okay, well, we know that we have to get, I'm going to underline in red, negative 9. That means we know that we have to have negative 1 here. So then if we continue that FOIL, 2x squared minus 9x, we're good. Then we just think, if that's a negative 1, we just have to put a negative 1 here to multiply by that x to get negative 1x. Then we can do the last step of FOIL. -1 times -1 is +4, and that's why k is equal to 4. Very common questions. Find k, or they give you one of the factors to find k. FOIL is going to be your best step. Doing all those reverse operations, FOILing the things out to really figure out what goes there. Okay, 15. We have a rectangle, and the area is x squared plus 5x plus 6. And we know one of the dimensions, let's call it the width, x plus 2, and we don't know the length. Could have switched those, doesn't matter. So we know the formula is A equals LW. And if the area is x squared plus 5x plus 6, we want to start seeing what we can do to it first. Well, we've been factoring in this chapter, so let's factor it. A equals, two numbers that multiply to get 6 and add to get 5 are going to be x plus 2 times x plus 3. Now we know one of the dimensions is x plus 2, therefore L must be x plus 3. So just using the knowledge of what we learned in a certain chapter to perform that skill and then decipher what the answer is going to be. Okay, so now it says find the dimensions and area if x is 3. So I'm going to redraw my diagram. And we know the dimensions are x plus 2 and x plus 3. And if we want to find the dimensions, if x is 3, we can replace x with 3. Therefore, we're going to have a width of 5 and a length of 6. And area is simply length times width, where the width is 5 and the length is 6. Then the area will simply be 5 times 6. Now, technically, we have centimeters, so then the area would have to be centimeters, 30 centimeters squared, with dimensions of W equals 5 centimeters and length equals 6 centimeters. Circle your answer. Notice we could have taken the 3 that we substituted in for x and put it straight into the area formula. So from above, we could have said 3 squared plus 5 times 3 plus 6, where the area would be 9 plus 15 plus 6 would also be 30 centimeters squared. So a lot simpler to find the area by redrawing the diagram and substituting into the diagram. Oh, forgot, so finding the length was A, and the second part, finding the area, was B. Okay, we have 16, very similar question. We have this time a square with an area of x squared plus 6x plus 9. I'm going to put ticks on the square, which means that this thing has to be a perfect square. So let's factor it. If A is equal to x squared plus 6x plus 9, then we can factor it. Two numbers that multiply to get 9 and add to get 6 are 3 and 3, so we get x plus 3 and x plus 3, and therefore x plus 3 squared. And because the formula for a quadrilateral is length times width, therefore A equals L times W, but if they're identical, we can just call them side lengths of S squared. Therefore, we know one of the side lengths will be x plus 3, and the other side length will be x plus 3. Circle your answers. So again, now find the dimensions if x is 3. Well, if x is 3, 3 plus 3 is 6. And again, 3 plus 3 is 6. And then the area is equal to length times width. So length times width. And then the area will be 6 times 6. And this time we have meters squared. So the area will be 36 meters squared. Okay, number 17. We have a rectangular prism with a volume of 3x cubed plus x squared minus 10x. Okay, find the dimensions and the volume if x is 1. So, first of all, we know that we're in our factoring chapter, so we're going to factor it. What can we factor? Well, we can factor out an x, and we're left with 3x squared plus x minus 10. Then we can do decomposition or guess and check. So we have our x out in front. Let's set it up. So two numbers that multiply together to make 3x squared are 3x and x. Then numbers that multiply together to make 10 are 1 and 10, or 2 and 5. And then we just need to figure out which combination goes where. So we need a -2 here and a +5 here. Excuse me? We have to switch those up. It's +2 and -5. So if we were to FOIL that thing out, we better get exactly the same thing as above. Let's do it in our heads. 3x times x is 3x squared. Good. 3x times 2 is +2x, is +6x. -5 times x is -5x. 6x minus 5x is x, that's what's above. And -5 times +2 is going to be -10. So the dimensions, it says find the dimensions. So we have length equal to x, a width equal to 3x minus 5, and a height equal to x plus 2. That order did not matter. Now, if x is 1, then the length will be 1, the width will be 3 times 1 is 1, minus 3 is, excuse me, if the length is 4, the length is 4, excuse me, not 1, 4, then the length will be 4. 3 times 4 is 12, minus 7. 12 minus 7 is 5. And the height, 4 plus 2, will be 6. Therefore, those will be the dimensions. And the volume will just be, excuse me, I forgot to say L equals 6. And the volume will simply be 4 times 5 times 6. 5 times 6 is 30. Therefore, we're going to get 5 times 6 is 30 times 4, 120. And let's get our units in there. Inches squared. Oh, I forgot to put dimensions on all the lengths. Length equals 4 inches. Width equals 5 inches. Length equals 6 inches. Don't forget your units. Remember, we could have just found the volume by substituting it into the V formula. But I like to find the dimensions separately and substitute into those. It's going to be a lot simpler. Okay, 18. So this time we have a triangle with an area equal to 1/2 x squared minus 2 meters squared. And I'm going to label the diagram. We have a base and a height, which we don't know. So let's start off with the formula. A equals, the formula for the area of a triangle is base times height divided by 2. Then we can substitute 1 over 2x squared minus 2 equals bh over 2. Now I have a 2 on the bottom, so I can times both sides by 2. When I times the first thing, 1/2 x squared by 2, the 2's cancel, I'm left with x squared. When I times the -2 by 2, we get -4. And then the 2 cancels, so bh. Okay, so what could the potential base and the height be? Well, let's factor the left-hand side. It's the differences of squares, x plus 2, x minus 2, equals bh. Therefore, a potential value for b could be x plus 2, and a potential value for h Could be x minus 2. Okay, so now we have the dimensions of B and H. Now they're saying to find the base and height if x is 3. So if x is 3, the base would be 5, and the height would be 3 minus 1 would be, 3 minus 2 would be 1. Let's get our units in there, meters, and again meters. And then the formula for area again, A equals BH over 2. A equals 5 times 1 divided by 2. A equals 2.5 meters squared. Again, we could have taken that 3 value and put it into the question, into the area formula, but it's much simpler to put it into the dimensions. So the triangle, a little bit more difficult. We could have done all sorts of different things with that 2 on the bottom, but I just like to substitute into both sides and cancel the 2 as soon as possible. Okay, we have number 19. So we have a square, and the area is 4x squared minus 20x plus 25. Notice we don't have any units. So let's take this thing all by itself. Let's start off, because they're talking about area, I'm going to write the formula for the area. Area equals s squared, or length times width. And we have 4x squared minus, excuse me, that's a 20. I'm going to put that in red. 20x, like the question says, minus 20x plus 25. And because the square root of 4 times the square root of 25 doubled is 20, it's a perfect square. So we can set up our brackets, and it's going to be 2x plus, 2x minus 5. We need to get negative 20. 2x minus 5, and again 2x minus 5. Therefore, each of the side lengths of the equal square will be 2x minus 5. So it says find the perimeter. So P equals, let's add them all up, 2x minus 5, or we could just times it by 4. So let's distribute that 4 backwards. P equals 8x minus 20. Circle your answer. Notice we didn't have an x value to substitute this time. Does it matter? No. Great. So notice we didn't have any units this time. Does it matter? No. The perimeter is that. Okay, number 20. We have a rectangular prism with dimensions of x plus 2, x plus 1, and 2x plus 1. And it's saying find the surface area and volume. Okay, so the volume will be a lot simpler. V equals LWH. Therefore, V equals x plus 2 times x plus 1 times 2x plus 1. So if we start by foiling out the first set of brackets, we're going to get x squared. Then we're going to get plus 1x plus 2x is plus 3x. Then 2 times 1 is positive 2. Then carry everything else down. Now we're going to have to do a triple FOIL. I'm going to skip a line for this. V equals. So x squared times 2x is going to be 2x cubed. X squared times 1 is positive x squared. Positive 3x times positive 2x is positive 6x squared. 3x times 1 is 3x. 2 times 2x is positive 4x. And 2 times 1 is positive 2. Then we can combine like terms. V equals 2x cubed plus 7x plus squared plus 7x plus 2. Circle our answer for the formula for the volume. Okay, now let's find the surface area. This is going to be a lot more difficult. Surface area. So we have a side length of x plus 2 and a side length of x plus 1, and there are two of those sides. Then we have a side length of x plus 2 of 2x plus 1, and there are two of those sides. Then we have a side length of x plus 1 and 2x plus 1, and again there are two of those. I'll again outline that one in red. There are two of those. So you'd have to FOIL everything out, then you'd have to combine like terms. They are never going to ask you for this question. It is just way too much work for the purpose. They'll definitely ask you the volume, but never the surface area. There would just be way too many steps. It might be a multiple choice question, and they'll say, what is the answer? Or feel free to FOIL it out on your own, but this review package is long enough already. All right, 21. So find the perimeter and area of this shape. Let's draw this shape. So not going to be perfect, but very similar to what it looks like. And we have ticks, and all of these ticks are all 2x, and the base is 2x plus 4. Okay, interesting. So let's first of all redraw this, or draw all the locations where 2x are. And then if we know that this length right here is 2x and 2x, then the whole length is 4x. Okay, so that's going to help. So I'm going to put 4x over here. And then let's start with the perimeter. So perimeter is going to be adding up all of the sides. So we have 4x plus 2x plus 2x plus 2x plus, let me count again, 4, 1, 2, 3, 4, 1, 2, 3, another 2x, plus the base 2x plus 4. So therefore the perimeter will equal 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14x plus 4, and let's get our units back there, centimeters. Okay, the area is going to be a little more difficult, so let's start with the formula for the area, A equals LW. So there's going to be a couple different ways we can do this problem. So if we start with the fact that we can cut it off here, for example, then we have to find two areas. So we know that the area on the top, A equals, well, we have length times width, 2x times 2x. Therefore, area equals 2 times 2 is 4, and x times x is x squared. Circle your partial answer. So that's going to be the area of the little bit at the top, the little square at the top. Now we have a rectangle, which the formula is also area equals length times width, which then we have the area of the length, 2x, or the width, doesn't matter, times 2x plus 4. Okay, well, what are we going to do with this? Well, we're going to have to distribute. So put our distribution lines in, and A equals 2 times 2 is 4, x times x is x squared, and 2x times positive 4 is positive 8x. Again, that's a partial answer. I'm going to circle the partial answer. Now to get a total, signified by a sub t, that would simply be them added together. So 4x squared plus 4x squared is going to be 8x squared plus 8x. Centimeters squared. Don't forget your units in your final answer. When we have multiple answers, we want to circle our final answer twice so it's clear to everyone that the answer is that, and we circled our partial answers only for our help. So teachers are going to give you better marks because they're going to have an easier time reading your tests or homework, for example, and just give you a better mark because they had a more enjoyable time reading your work. Great. So that is the perimeter and the area of that shape. Keep in mind, I'm going to draw a red line in the diagram at the top. So I'm going to fill in the square. Then I'm going to draw that diagram way off to the right. So now it's just one big square with a bottom of 2x plus 4 and a side of 4x. We could have found the area of that square and then just subtracted the area of this square. So keep in mind, there's going to be all sorts of different ways to do it. The teacher cannot tell you the type of way that you can logically solve a problem. As long as you can figure it out in a logical fashion and show exactly what you did, then it's okay either way. So we have the perimeter and area of a shape. All right, 22, we have a right angle triangle with the 90 degrees. And it's asking us for C, the hypotenuse, and we have a dimension of the base, 2x minus 1, and we have a side of 3x. Okay, and it's asking us for an expression of the hypotenuse of the right angle triangle. Well, what do we know about right angle triangles? We know that a squared plus b squared equals c squared. Okay, that's helpful. So let's start squaring things. So a, the base, is going to be 2x minus 1 squared. And we know that squared just means times itself, so I'm going to do that right now. Then we have plus. So then we have 3 minus x. And if we're squaring that as well, we know that's just 3 minus x. And then we can say equals c squared. Okay, so let's FOIL these things out. So we're going to get 4x squared. Then remember earlier we learned to combine like terms in the same time, skipping a step. So 2x times negative 1 is negative 2x. And again, negative 1 times 2x is negative 2x. And negative 2x minus 2x is negative 4x minus 4x. And negative 1 times negative 1 is positive 1. Then it's nice, we have a positive sign in front of the bracket, so we don't have to distribute any negatives. We can start off with that positive sign, and we can FOIL these brackets. 3 times 3 is 9. 3 times negative x is negative 3. Negative x times 3 is negative 3x. Negative 3x minus 3x is negative 6x. And then negative x times negative x is going to be positive x squared equals c squared. Okay, interesting. So now we have some like terms. So we have 4x squared plus x squared. So we have 5x squared. Then we have negative 4x minus 6x. So we get negative 10x. And then we have plus 1 plus 9 is going to be 10. So plus 10 equals c squared. So now we have a squared. We can find the expression for the value of c simply by square rooting both sides. The square root, like we learned in Pythagoras' theorem, is going to cancel the squared. So we have the expression for the hypotenuse of the right angle triangle. Does it matter that we don't know exactly what it is? I mean, possibly if we could factor the inside, we would continue, but we don't. So we can just say c equals the square root of 5x squared minus 10x plus 10. Circle your answer. An expression for the square root. So common in math, students think we have to find some exact, easy, nice, clean answer, but we don't all the time. Sometimes they just say find something. That's this. We can't do anything else based on our methods. Therefore, this is the final answer. Okay, we have another right angle triangle, and in this case they drew the definition of Pythagoras' theorem. So we have a squared, c squared, and b squared. When this length is a, this length is b, and this length is c of our hypotenuse right angle triangle. And they've given us some length. So they said that b squared is equal to x squared plus 2x plus 1. And they've said that c squared equals x squared plus 4x plus 4. Interesting. Okay. So it's first asking us for b and then a squared. So, I forgot to finish off b. X squared plus 2x plus 1. I did that in red. So it's first asking for b. So we have to think, well, b, okay, what can we do? How can we find b? Well, we've got this squared here. So we can square root both sides. So then therefore b equals just the square root of x squared plus 2x plus 1. And then in the last question, we couldn't factor it or do anything, but this one we can. So let's factor it. What are two numbers that multiply to get 1 and add to get 2? X plus 1 and x plus 1. Still square rooted. B. Therefore, B equals the square root of x plus 1 all squared. Therefore, B equals x plus 1 because the square root reverses the squared. Circle your answer. So it's just an interesting side question. They don't always tell you exactly what to do. You just have to come up with some sort of idea from all of the methods that you've learned in the past. Okay, now it's asking us for a squared. So we know a formula for a squared. A squared plus b squared equals c squared. Okay, and they want a squared, so why don't we just start by subtracting b squared from both sides. Okay, so then we can say a squared equals c squared minus b squared. Okay, so then a squared will be exactly what c squared is, x squared plus 4x plus 4 minus what b squared is. And I have to substitute with brackets, open bracket. X squared plus 2x plus 1 from our b value earlier in the question. What b squared was, excuse me. So now we have to distribute that negative. So we get a squared equals x squared plus 4x plus 4. Then we're going to distribute the negative, minus x squared minus 2x minus 1. Then we can combine like terms. A squared equals x squared minus x squared is gone. 4x minus 2x is going to be 2x. And 4 minus 1 will be positive 3. Circle our answer. So they asked us for what a squared was, so we gave them what a squared was. We don't need to square root both sides because they're not asking for what a is. So we've clearly found what b and what a squared are. A very idiosyncrasy type of question about Pythagoras' theorem, and there are so many more. Okay, 24. Find the area of the shaded region below between the two rectangles. So let's draw these two rectangles. And then they've said that this side is x minus 6, and this side is 2x plus 11, and this side is x plus 5, and this little side is x minus 2. Notice the locations of where I drew these. They're in the exact best location possible. Sure, there could be some alternatives, but these locations clearly define all of the lengths that we need, and we're looking for this shaded region. So this might be some sort of a pool deck around a pool or a garden walkway word problem. Okay, so in order to do that, we're going to have to take the big rectangle and subtract the small rectangle to give us the shaded bit. So that means we need to find the area of both. So area of a rectangle is length times width, and the big one is 2x plus 11 times x plus 5. And I'm going to set it up right now. The area of the small one is x minus 6 times x minus 2. Okay, so if we FOIL these things out, we get a equals 2x times x is 2x squared, 2x times 5 is positive 10x, hold that thought, 11 times x is 11x, and 10x plus 11x is positive 21x, and 11 times 5 is positive 55. X times x is x squared, a equals x times x is x squared, x times negative 2 is negative 2x, negative 6 times x is negative 6x, negative 2x minus 6x is negative 8x, and negative 6 times negative 2 is going to be positive 12. So then the area of the shaded region, a sub s, I could have circled my partial answers if I wanted to, but I didn't this time. So then the area of this will just be the bigger area, 21x plus 55, minus brackets the small area. So we're going to have to distribute that negative. So a sub s is going to be everything above. I'm not going to write it because I'm just going to distribute the negative. Then I have to write all those steps down anyways. Minus x squared plus 8x minus 12. Now I'm going to work on 2 lines at the same time because I was lazy and didn't want to rewrite every single step. You should start to get used to doing that. So the area of the shaded region will be 2x squared minus x squared is x squared. 21x plus 8x is positive 29x. And 55 minus 12 is going to be positive 43. Circle our answer. The area of the shaded region above. The area between the 2 rectangles. Okay, 25. We have a circle inscribed in a square, meaning it touches on the outside. And we have the length of the bottom of the square being 12x minus 4. And I'm going to tick all the sides because it's an equal square. So it says find an expression, expanded form for the circumference and area of this circle inside this square. It should say inscribed in this, oh it does, good, inscribed in this square. So, first things first, we have something that can be factored. But I'm just thinking about factoring because I'm in the factoring chapter. So I'm just going to factor it just for fun. I can factor out a 4. 4 open bracket, x minus 3. Was that useful? Maybe. I don't know. I just thought about doing it, so I did it. All right. So they want the circumference of a circle, c equals 2 pi r, and the area, a equals pi r squared. Okay, so we have this 12x minus 4, and it's the length of the square, side length of the square, which is equal to the diameter of the circle. But we want only the radius. So we need to take 12x minus 4 and divide it by 2. 12 divided by 2 is 6, and we need an x, and negative 4 divided by 2 is negative 2. And that is the radius. Circle that partial answer for the radius. So we can take that radius and we can say c equals 2 times pi times 6x minus 2. Then we can put it in for the area. A equals pi open bracket 6x minus 2 close bracket squared. Substituting at the same time sometimes. They asked us for both circumference and area. We may as well substitute it both in the same time. Sometimes we might even forget to do the second part of the question. Okay, so I'm going to leave this question in terms of pi. I'm just going to distribute the 2 pi into the question. Keep in mind, it's already in factored form. You could probably circle your answer and it would be fine. But let's distribute the 2. So c equals 2 times 6 is 12. Then we need an x. Then we need a pi. Could have done that in a different order. Minus 2 times 2 is 4. Then we need a pi. So I'm going to circle both answers to show that the teacher, I know that my first answer is probably actually better in factored form. Keep in mind, we could have further factored the brackets, so technically it wasn't as factored as possible. I could say c equals 2 pi. Then I could factor out a 2 from the brackets. I'd be left with 3x minus 1. Then I could combine the 2's in front. 2 times 2 is 4. So 4 pi 3x minus 1. And that would actually probably be the best simplified answer for the circumference. Okay, area. So a equals, we have pi this squared. So remember, we can be lazy. If we have a squared, we can just cross it off and rewrite the term beside it. Then we can FOIL it out. So we get 6x times 6x is 36x squared. Then 6x times negative 2 is negative 12x. Then we have another negative 12x, so we have negative 24x plus 4. Close bracket, circle your answer. We could distribute the pi, but then we just have to refactor the pi out anyways. Does anyone notice something that we could actually factor out of the brackets? Ooh, a 4. So let's do that. A equals 4 pi open 9x squared minus 6x plus 1. Check my answer by distribution. 4 times 9 is 36. 4 times negative 6 is negative 24. 4 times 1 is 4. Then we would think, possibly, can we factor the brackets? Do we know two numbers that multiply together to make 9? 9 times 1. Add together to make 6? Yes, we do. So, if everyone remembers, if we take the square root of the first thing times the square root of the last thing and double it, that's 3 times 1 times 2, which is 6. And the signs work out. This is a perfect square. So we know that A equals 4 pi. Set up our brackets. Two identical numbers that multiply together to make 9x squared are 3x and 3x. Two identical numbers that multiply together to make 1 are 1 and 1. They both need to be negative in order to get negative 6x when you FOIL it out. A equals 4 pi, 3x minus 1, all squared. Now, if that factoring is possible, I would absolutely put one single line through my last line showing that. I shouldn't have stopped there. I should have thought about all of my other factoring types, and that is a great example of combination factoring, factoring out a GCF, factoring perfect squares, etc. Great question. All right, question number 26. Notice in the last question I numbered it correctly, but the title at the top was actually one question before. It doesn't matter. Okay, so we have R and we have 3. Okay, find an expression for the area of the shaded region. Okay, so we're talking about circles, so I'm going to draw the big circle off to the right and the small circle. The small circle has a radius of r, and the big circle has a radius of r plus 3. Okay, so we're talking about areas. So area of a circle is equal to pi r squared. And I know that in order to get the shaded part, I have to do the bigger one minus the smaller one. So I'm going to start off with a equals pi r squared. So notice the area of the small circle is already completed. And the area of the big circle, a equals pi r plus 3 squared. Remember, squared means that thing times by itself, and we can FOIL it out. A equals pi r squared plus r times 3 is 3r, 3 times r is 3r, plus 6r, 3r plus 3r is 6r, plus 3 times 3 is 9. So then we can distribute. So a equals pi r squared plus 6 pi r plus 9 pi. And then the area total, or area shaded, excuse me, let's go for area sub s, not a sub t, will be the big area, pi r squared plus 6 pi r plus 9 pi. And then I have to minus, I'm going to put it in brackets, the smaller area, pi r squared. So these brackets are unnecessary because I don't have a binomial inside. I don't have to distribute the negative. I can just scribble out the brackets and know that term is negative. Then I'll know that the area of the shaded region, pi r squared minus pi r squared is gone, will be 6 pi r plus 9 pi. Circle our answer. Great. So interesting, when they just ask you for the expressions of things and you don't actually have to find a final answer with numbers, sometimes it's very confusing as to what to find. But this is an expression for the area. If, for example, they gave us units, we would have just said those units squared beside. Okay, 27. So we have a circle and its area is equal to 9 pi x squared plus 36 pi x plus 36 pi. And they're asking us for an expression of the radius, and we know that area is equal to pi r squared, and the circumference, and we know that c is equal to 2 pi r. So we can start off on the formula that we were given, a equals, and we can start to manipulate it. So first things first, the greatest common factor between 9, 36, and 36 is going to be 9, and they also all have pi, so we can take it a pi. Then we're left with x squared plus 9 times 4 is 36. And again, we need an x, and then 9 times 4 is going to be 36 again. So look at these brackets. Well, they can be factored. So we can say a equals 9 pi, and then we can factor the brackets, so it's going to be x plus 2, and we know that if we have two identical factors side by side, we can just call it squared. Now they want a formula for the radius, so I'm going to write the formula for the area again. A equals pi r squared. So we need pi, we have it, and we need r squared. Well, the rest of it says 9 that squared. But is that the radius? What's the radius? Well, it's not just x plus 2 because we have a 9 there. We actually have to do perfect squares and call this 3 open bracket x plus 2 all squared, and that's what the radius is equal to. Because if you square 3, you get 9, and if you square x plus 2, you get x plus 2 squared, and that's what it says. So it's like the formula is a equals pi r squared. Now if a equals pi, then r, that thing, well, we have to square the 3 and square the bracket, so a equals pi 9 x plus 2 squared, which is where we started from earlier, so that is the expression for the radius. Then if we write the formula for circumference again, notice I wrote the formulas down earlier and I'm writing them again. I wrote them earlier because I wanted to be reminded of those formulas and know what I'm looking for and sort of have a guide as to what I'm going to be finding in the future. And then I'm going to write it again because I want to very carefully substitute into it and I don't want to make any mistakes. So the area from above is 3 open x plus 2 all squared. We know we can square that 3 to become 9, and then we can multiply the 2 and the 9 together and get 18 pi x plus 2 all squared. Now, should we FOIL that out? No, because we just have to refactor it to be back where we were anyways. Very interesting question. We have a circle with an area, and you have to find the radius and then the circumference. Lots of different factoring styles and a few idiosyncrasies for the more advanced students. All right, question number 28. We have a area model. Okay, so we have x and x represented by rectangles colored in as per the legend below, and that's 2x. Then we have a -1. So inside the area model, we have an x squared represented in the legend below. We have 2 of them, so 2x squareds. We have 4 x's, 4 rectangles. And then we have a -x, a vertical rectangle, not colored in, and we have 2 -1s. So we need to figure out what goes on the far left. So I'm going to draw in some lines of division that separate this thing. We can't cross the lines. So in red, you know what, in blue off to the left, I'm going to put one of these here, one of these here, and one of these here. Just that simple. Now we just need to think in this tabular format, multiplying things together. x times what is x squared? Well, we're going to have to make it positive. And then x times x is x squared, and then negative 1 times x is negative x, so the first row is good. Then positive x times what is positive x? Positive 1, so we need to color that one in. And then confirm x times 1 is x times 1 is x, negative 1 times positive 1 is negative 1, good. And that'll be the same for the second, which means we have x plus 2. Circle our answer. So that's one way to do it. The other way to do it is put what's inside. 2x squared plus 4x minus 1x minus 2. Combine like terms. 2x squared plus 3x minus 2. Then factor it. Two numbers that multiply together to make 2x squared are 2x and x. Two numbers that multiply together to make 2 are 2 and 1. We need to have the 2 here and the 1 here, and the 2 has to be positive and the 1 has to be negative in order to get that middle term, x 3x. I'm going to confirm by multiplying it out. 2x squared plus 4x minus x minus 2, and therefore it is factored correctly. So I'm going to circle that partial answer. So notice we can clearly see that there's a 2x minus 1 on the top. So we know that our answer is simply x minus 2, plus 2, excuse me, the other factor, also seen by the area model. So remember, if you don't like the area model, just fake it. Factor the thing in the middle, figure what the factors are, put that on the top and the left, and then you've got your answer, and then just draw in the area model and erase what you did. Remember, area models are a little bit silly. The fact that x is 2 dimensions throws out the complete logical concept of it. But don't worry about that. Just do exactly what your teacher says and understand how these area models work and how they relate to factoring. Okay, 29. We have a triangle with an area of 18x squared. And it's asking us for the height when the base is equal to 4x. Okay, so we have a triangle, and the formula for the area of a triangle is a equals base times height divided by 2. So we know that the area is 18x squared. We can substitute that in for the area on the left-hand side of the equation. And then we know the base is 4x. And then we know the height, or we're looking for the height, so h, and then over 2. Now, I could just simplify the 4 over 2, and it would just be 18x squared equals 2x. 4 divided by 2 is 2. H. Then I could just divide both sides by 2x. And I'll mirror it. H would equal 18 divided by 2 is 9. X squared divided by x is x. And circle our answer. We have the height. But let's do it in a different way, because what if that doesn't divide and you want to be able to have the skill? So we have a 2 on the bottom. We want to times both sides by 2. The 2's on the right will cancel. 2 times 18x squared is 36x squared equals 4xh. Then we can divide both sides by 4x. Then we can mirror it. Therefore, h equals 36 divided by 4 is 9. And again, x squared divided by x is x. And we can circle our answer. So remember, multiple different ways to do problems. Sometimes you may see one solution. Sometimes you may see another. As long as you have logical algebraic steps to show the work that your teacher requires, you will get the mark. So, bringing a little bit more geometry back into it, where we have areas, given areas, and then doing algebra to solve for the solution. So, let's check our answer. So, a equals bh over 2. A equals, the base is 4x given. The height is 9x, solved for a second ago, over 2. A equals 9 times 4 is 36, divided by 2 is 18, and x times x is x squared. Circle, no, don't circle that answer. That's just checking our answer. Put a check mark beside the answer 9x that you got earlier. So, no really need to check your answer on these, but it's just a great confidence booster. Building your skills to know at home, you can know if you had the correct answer if you're not given the solutions. Okay, number 30, we have a rectangle, and they're giving us the area of 2x squared plus x. And they want us to find the width when the length equals x. So, we know that the formula is A equals LW. Now, some people may just take A equals LW, and they're looking for W, so divide both sides by L. Therefore, cross off the L's and W equals mirror it, A over L. This is one way to do it. So then W equals, take the area of 2x squared plus x and put it over the length x. Then we're going to separate our fractions, 2x squared over x plus x over x. W then therefore equals, x squared divided by x is just going to be x, so we're left with 2x. And then x divided by x is 1, 2x plus 1, circle your answer. So that's isolating for the variable before we find it and then substituting. What else we can do is substitute in for a right away. 2x squared plus x equals LW. So, we have L. So L is x, so XW. I'll give you a second to erase that and recopy that down. So, now we've been factoring. So on the left-hand side, we can factor out an x. X open bracket, 2x plus 1, check by distribution. X times 2x is 2x squared. X times 1 is x, we're good, equals xw. Then we can clearly see that we have an x on both sides. So then we can clearly see that w is the rest of it. W equals 2x plus 1. Circle your answer. Notice it's the same. Let's check our answer. So A equals LW. So now taking L, the x value, and then the w value we just got, 2x plus 1, distributing A equals x times 2x is 2x squared, x times 1 is positive x. That is the area from the question, therefore we know our answers are correct. Okay, 31A, we have a rectangular prism with side lengths of x minus 2, x plus 2, and x plus 3. And they want an expression for the volume. So V equals LWH. Therefore V equals x minus 2 times x plus 2 times x plus 3. Now, which set of brackets should I FOIL out first? Well, I want to recognize the first two set of brackets is a difference is a square. So if I FOIL that one out, I'm going to get V equals x squared minus 2x plus 2x minus 4. Still, carry the rest down. Now I have a negative 2x plus 2x. I can cancel them. So then V equals x squared minus 4 times x plus 3. This will be a simpler FOIL. Second round. So V equals x times x is x cubed, x squared times 3 is positive 3x squared, negative 4 times x is minus 4x, and then negative 4 times positive 3 is positive 12, and we can circle our answer for the expression for the volume. Now they're saying that x is equal to 5. So where do you want to put it in? You want to put it in here, or do you want to put it into the diagram above? Let's put it in the diagram above. I'm going to simplify the diagram down below. Now the bottom length is x minus 2. 5 minus 2 is 3. The side length is x plus 2. 5 plus 2 is 7. The height is x plus 3. 5 plus 3 is 8. And then the volume is simply going to be length times width times height. V equals 3 times 7 times 8. Therefore, V equals 56 times 3, which is 168. Now, notice the question didn't give us any units. Oh, there are centimeters. So, centimeters cubed. They give us centimeters. I forgot to write centimeters above in the given information in part B. Excuse me, I forgot to write part B. So, finding the volume when x is 5. Now, couldn't we have substituted into the crazy volume formula from above? Let's find out. V equals, open bracket, 5. our x value that we are using. Cubed plus 3 open bracket x minus 4 open bracket x plus 12. Oh, forgot to substitute those x values. So I'm just going to erase those x values. I'll let you do that as well. And the x value that we're substituting in is 5. So v equals 125, 5 cubed, 3 times 5 is 15. Four times 5 is 20, plus 12. 125 plus 15. Minus 20 plus 12 is equal to 132. Those aren't the same. So one of our answers wrong. Which one are we more confident with? The first one. So what did I forget in the formula? Look at how I was so lazy and I just drew an arrow from above down below. I didn't even write the formula down. I'm going to write it down. V equals x cubed plus 3x minus 4x plus 12. Now wait a second, that doesn't look right. Okay, so let's go back up and look at our volume formula. The first step of FOIL, x squared times x, is definitely x cubed, good. Oh, cool, look at this. X squared times 3 is in red 3x squared. Negative 4 times x is negative 4x. Negative 4 times 3 is 12. Therefore, the rest of the terms are correct. And we're missing the squared. I'm going to write that down below twice in blue. Squared, squared. Which means our term in the middle is not 15, but 25 squared. 5 squared is 25 times 3 is 75. And then when we add up all those numbers, it's not 132, it is 168. Like we got before, so we know we're correct. So, notice, I could edit these videos when I make these mistakes sometimes, but it's going to be a much more useful tool for you to understand how to solve problems. We don't just get upset and start to worry about what we did wrong. We carefully and confidently go through each one of our individual steps and decide which one's correct or incorrect. So often, such a good idea to do a math question in two separate ways, so that if you know that they're different, then you know that one of the answers is wrong. You can then go to your least confident step and start working towards your most confident step to try and find the error until the answers are the same. Okay, so that was 31A and B. Find an expression for the volume and the volume if x is equal to 5 centimeters. Notice I forgot centimeters cubed in my answer for the expression of the volume. Okay, we have 32A. So look at this, we have a rectangle and the area is 2x squared minus 5x minus 12, and we have a width of x minus 4, and we're wondering what the length is. Okay, so find the length. So let's take the area formula down below, 2x squared minus 5x minus 12, and recognize that we can probably do something with it. So let's first of all write the formula A equals LW. Okay, we need two things that multiply together to make this thing. Well, again, in the past, we've done all sorts of different methods like substitute for A, or divide both sides, or times both sides. But we know we're going to be factoring this thing. And so often, they give you one of the factors in the question, so you can do a way easier time doing it. So we are going to factor this thing, and we know it's going to be 2x times x, because 2x times x is 2x squared, and that's what's above. And now we wonder what's in the second set of brackets. Well, they've given us x minus 4 above, so we know it's minus 4. Then we can just think about what goes there. We have to get negative 12, so we have to put a positive 3 here. Therefore, the length is just equal to the other factor, 2x plus 3. So then we can check our answer. So off to the right, A equals our length that we just figured out, 2x plus 3. I forgot to circle my answer. Notice there aren't any units. Sometimes there's just no units. And then times the width, x minus 4. FOIL this thing out. 2x squared. 2x times negative 4 is negative 8x. Positive 3 times x is positive 3x. Negative 8x plus 3x is negative 5x. And then 3 times negative 4 is negative 12. Because that's the area from the question that was given, check mark. Always doing the reverse operation to check your answer. The length is 2x plus 3. Okay, B, now find the area if x equals 9 meters. Okay, let's redraw this diagram. So we have x minus 4. 9 minus 4 is 5. Then the length, oh, I forgot to put it in the diagram above. 2x plus 3, circle any found information in a diagram. So 2 times 9, 2x plus 3, 2 times 9 is 18, plus 3 is 21. Therefore, the area will be length times width, or 105 meters squared. Let's check our answer. So notice they gave us the area formula, a equals 2x squared minus 5x minus 12. Let's substitute 9 into that answer and make sure that it's correct. So we get 2 open bracket 9 close bracket squared minus 5 open bracket 9 close bracket minus 12. Then we can type that into the calculator. 2 times 9 squared minus 5 times 9 minus 12 is also a equals 105 meters squared. Notice it's the same as our answer that we've already circled already. That was just checking our answer, so we can say check mark. Doing an alternate method to make sure that the answer is the same is just as important as checking your answer as doing a reverse operation. Okay, we have a question 33. So we have a rectangular prism and the volume is x cubed plus 5x squared plus 6x. So we know that the formula for the volume is V equals LWH. So we need to find 3 things that multiply together to make this thing. And we're in the factoring chapter, so we're probably going to factor this thing. So first things first, we can remove the greatest common factor of x. We can take it on x, and x times x squared is x cubed, and that's what's above. And x times positive 5x, and x times positive 6. Then we have a trinomial. V equals x open. 2 numbers that multiply to get 6 and add to get 5 are 2 and 3, so we get x plus 2, x plus 3. Then we can circle our partial answer, our factored form of the volume. Therefore, the question is asking for find possible expressions for the dimensions. So, well, length could be x, width could be x plus 2, and the height could be x plus 3, or any combination of those. Feel free to FOIL all those out and make sure that the answer is the same as it was before. So let's do that. V equals. Now I'm going to do some very interesting steps of FOIL. I'm going to start on the brackets. X times x is x squared, and times the x in front is x cubed. X times 3 inside the brackets are x, 3x. 2 times x is 2x, 3x plus 2x is 5x, times the x in front is 5x squared. And 2 times 3 is 6, times x is positive 6x, which means that we know that we are absolutely correct. Keep in mind there may possibly be more answers to this, and keep in mind the length, width, and height order do not matter. Okay, 34A, we have a rectangular prism with dimensions of x plus 1, sorry I didn't finish my prism, x plus 1, x minus 1, and we don't know the height. But they've given us a volume, V equals x cubed plus x squared minus x minus 1. Great. So let's figure out what that volume is. Or work on it. So what type of factoring could we do here? Well, we couldn't factor an x out of the first 3 terms because the last term doesn't have an x on it. So let's try grouping. So brackets are on the first two things, brackets are on the second two things. Let's remove our greatest common factor from both sets. So v equals, we can take out an x squared, and we're left with x plus 1. X squared times x is x cubed, and x squared times 1 is x squared. Then we can take out a minus 1. Then we have x plus 1, because negative 1 times x is negative x, and negative 1 times positive 1 is negative 1. So then, I'm going to leave out the v equals for the moment. So then we have x plus 1. They both have an x plus 1, so we can take out an x plus 1. And then we're just left with this and this. X squared minus 1. Okay, interesting. Well, this second part can be factored. It's a differences of squares. So we can say x plus 1, then we can factor the x squared minus 1, which will be x minus 1, x plus 1. Because the formula is v equals LWH, and we now have three factors, 1, 2, 3, well then, we know that this missing dimension is just the dimension that's not there. So we have a dimension of x plus 1, a dimension of x minus 1. We'll need another dimension of x plus 1, and that is the height. Now it's saying find the volume, so B. Now it's saying find the volume if x is 4. So again, I'm going to redraw that diagram. And then if x is 4, our dimensions will be x plus 1 will be 5, x minus 1, 4 minus 1 will be 3, and again x plus 1 will be 5, and we'll get a volume of 5 times 5 is 25, length times width times height, any order you like. 5 times 3, v equals 5 times 5 is 25 times 3 is 75. And I forgot our units, inches cubed. I forgot our units above as well, 4 inches. So we can circle our answer. And feel free to go ahead and take v and put it into any line you like, but more specifically this one, and make sure that it's 75 inches cubed. But I've already checked my answer doing enough reverse operations and alternate methods. So finding the height and the volume if x equals 4 inches. Okay, 35, we have an open top box. I'm going to draw that box and connect the corners, and I'm going to shade the top to show that it has an open top. Now it says we have a square base. I'm going to tick those lengths and call them x. Now it was made from cutting equal lengths of 2 centimeters from each corner of a square piece of cardboard. So let's draw that square piece of cardboard. And we're cutting off corners of equal lengths and cutting them off. So then when we fold them up, we get this shape right here. Now they're saying we're cutting off lengths of 2. So we can put 2 on all of our corners. Okay, so what's the formula for the volume? Well, it's v equals LWH, and specifically v equals x times 2, because we have a height of 2. Because if we fold up the corners geometrically, the length of the part that we cut off is exactly equal to the height. Feel free to draw this diagram and make cutouts, and then make an open top box by folding up the corners and taping it together. It'll help. So notice they've told us that v is 50 centimeters cubed. We can take that and we can put it into the left-hand side. So 50 equals 2x squared. We can divide both sides by 2. X squared equals 25. We can square root both sides. X equals plus minus 5. We can reject the negative because we have to have positive lengths. X equals 5. Partial answer, circle it. But it's saying find the size of the cardboard needed. So if x is 5, then that means this is a 5 and this is a 5. And our total length will be 5 plus 2 plus 2 is 9. And again, 5 plus 2 plus 2 is 9. So 9 is the side length. I'm going to circle my square piece of cardboard twice and put 9 on both of its lengths. 9 centimeters is the length of the size of the cardboard needed when you cut off little corners of 2 for it to fold up to have a volume of 50 centimeters cubed with an open top. Okay, 36. So an open top regular box again. Let's draw that open top rectangular prism. And we will shade the top again. Is cut from a piece of rectangle, and the corners are cut off like in the last question, and we're going to fold up the sides. So the piece of cardboard was originally 15 by 12. So we need to let x equal the length cut. So we can put x in all the lengths cut. So what will our dimensions of the rectangular prism be up to the left? Well, if it was 15 and we're cutting off x twice, it's 15 minus 2x. If it's 12 and we're cutting off x twice, it's 12 minus 2x. And if we're cutting off x and we fold it up, again, if you don't fully understand this geometrically, print this page off, cut off the corners, fold up all the sides, make sure it's an open top box, and then we'll have a height of x. Therefore, our dimensions could be w equals 15 minus 2x, L equals 12 minus 2x, and h equals x. Circle your answer. So that's going to be the conclusion of our polynomial exam review. I hope we had enough questions to show you all the idiosyncrasies of all the types of factoring, and then bring it up into the most appropriate word problems, mostly geometry, among others.